Good morning, students. Today we are going to discuss about that module number 2, that is network theorems. Here we are going to discuss about that Thevenin's theorem and problems on Thevenin's theorem. Let us discuss about that Thevenin's theorem. Thevenin's theorem is nothing but one simple technique which is used to reduce the complexity of the given circuit as to find out that unknown response. According to the statement of Thevenin's theorem states that in any two-terminal linear bilateral circuit, the voltage sources and current sources can be replaced by a simple Thevenin's equivalent circuit consists of a Thevenin's voltage VTH which is connected in series with RTH across the terminals AB in the circuit shown in figure, whose voltage value, that is Thevenin's voltage value, is equal to open circuit voltage and whose Thevenin's resistance, that is RTH, is equal to equivalent resistance of the given circuit, whose equivalent resistance value, while we are calculating, the given voltage sources of the circuit has been short circuited and current sources has been removed from the circuit as to find out the RTH across the terminals AB. This is the statement of Thevenin's theorem. Let us see that how the Thevenin's equivalent circuit here. So Thevenin's equivalent circuit, according to the statement, it consists of one Thevenin's voltage VTH and a Thevenin's resistance RTH. Both are connected in series across the terminals AB. So by using this simple Thevenin's equivalent circuit, any given circuit can be modified into Thevenin's circuit. Why we have to modify any given circuit into Thevenin's circuit? Because in a circuit which consists of 2 loops, 3 loops, to find out the response at beyond the element, that time we have to approach current division rule. We have to find out the currents by 2 times and 3 times or multiple times. It takes lot of time to find that unknown response. As to reduce that time consumption in terms of calculations and to reduce the complexity while we are calculating that unknown response by using that current division rule, or for example nodal analysis, or for example like mesh analysis, this simple Thevenin's equivalent circuit can make that complicated circuit into very simplified manner, which consists of only one VTH value and RTH value which are connected in series. So at the end of that Thevenin's equivalent circuit, we can connect that load resistor and we can find out the value of R here. So this is that one simple way how to find out the unknown response by using that Thevenin's equivalent circuit. So by using the Thevenin's equivalent circuit, we are simply reducing that complexity of the circuit and we make into a simple circuit which consists of only one loop circuit, that is Thevenin's equivalent circuit. To verify this Thevenin's equivalent circuit, let us go through that a problem which has been shown on this figure. Using the Thevenin's theorem, find the current I through R is equal to ohms. So this is the circuit what they given for us. In this circuit we have to find out that the current flowing through R is equal to ohms here. So we have to find out that current, that is I, which is flowing through that R is equal to ohms. So R is equal to ohms is connected extremely in the circuit at the terminals AB. So for these terminals AB, the left side circuit consists of one T-section network which consists of 2 series arms like 5 ohms and 4 ohms and one shunt arm resistance as 20 ohms, which has been connected to that 150 volts voltage source at here. Now we have to find out that current I which is flowing through that R is equal to ohms. This is our ultimate aim according to the given problem using Thevenin's theorem. So according to the statement of Thevenin's theorem, as we know that very clear, whatever the circuit they given in the problem, we are going to convert that circuit into this simple Thevenin's equivalent circuit model. So where we have to find out two unknown parameters. One is called as VTH value, that means Thevenin's voltage value, and RTH value, that is Thevenin's resistance value. So now our aim is to find out that VTH and RTH for this circuit. So let us find that VTH. VTH is nothing but open circuit voltage. To find out that VTH, that is called as open circuit voltage for the given circuit, I am removing the element or a branch resistor which they are given in the problem, that is 2 ohms resistor across the terminals AB, what they are given. I am removing it and I am looking through that AB terminals to find out that open circuit voltage VOC or Thevenin's voltage VTH. So now I want to find out that Thevenin's voltage at the terminals AB. If I want to find out that Thevenin's voltage at the terminals AB, so from the terminals AB I want to apply the KVL. If I want to apply the KVL from the terminals AB in clockwise direction, by assumption that a current which is flowing at here, like I write the KVL equation. If I am going to write the KVL equation for this circuit by analyzing the current I which is flowing at here, then here I got, but these are the polarities, so minus VA plus 4 into I plus 20 into I is equal to 0. So here it is AB terminals are open circuited, no current here which is flowing, but here 20 is nothing but mutual resistor for this loop and this loop. So through 20 there are two currents, I plus I. If it is I plus I means from right hand side one current I is equal to 0, from left hand side there is one current. What is that current? We have to know. That means if you simplify this equation, here we got this value I is equal to 0. So minus VA plus 20 I is equal to 0. So VA is equal to 20 I finally. VAB terminals is equal to 20 I. So now VAB terminals is equal to 20 I. VAB, that is open circuit voltage, that is equal to 20 into I. But I want to find out the current I. It is not possible to find out the current I from the terminals of AB. We have to find out the current I from the given circuit from the left side loop. In the left side loop already they given that one hint to us, there is a current I which is flowing in clockwise direction here. So what is I here in this loop? In this loop the current I is equal V by R equivalent. V means here 50. R equivalent is nothing but 5 ohms and 20 ohms are connected in series. 5 plus 20, it becomes 25. So the answer is 50 divided by 25. 50 by 25 it is 2 amperes. 50 by 25 it is 2 amperes. Now I am going to substitute VAB. What is the formula of VAB? Just now I told that VAB is equal to 20 into I. Now I is equal to amperes, 22's 40 volts. 40 volts is nothing but VAB. VAB is nothing but open circuit voltage, and it is also called as VOC, or it is also called as VTH. Thevenin's voltage VTH is equal 40 volts. So from case 1 here we are calculated that VOC is equal 40 volts. Now it is the time to find out that Thevenin's resistance called RTH. How to find out that Thevenin's resistance? While we are finding that Thevenin's resistance in the given circuit, if there are any voltage sources, we have to short it by considering its internal resistance, and if there is any current sources, we have to simply delete it by considering its internal resistance. Then the simplified circuit has become as like this, what I am showing here. So in this circuit we have to find out the R equivalent value. How to find out the R equivalent value or RTH value? RTH value here we can find out from the terminals AB. If you look, what about that RTH? From the terminals AB, if you look about, we have to do analysis. Let us imagine there is a voltage source at the terminals A to B. Then it drives one current. That current divides at this node. one current will flow as like this, for example IA, and another current will flow like this, for example as IB. IA and IB are the two different currents, therefore these 5 ohms and these 20 ohms are connected in parallel, and again it is series with 4 ohms. If it is like that, then R equivalent value can become as 5 ohms is parallel with 20 ohms, and again it is series with 4 ohms. If you do the simplification here, 5 ohms if it is parallel with 20 ohms, that is 5 into 20 will be 5 plus 20 and plus 4. 25 is 20 into 5, 25 is divided by 5 plus 20 and again plus 4. So 100 divided by 25 plus 4. 25 ones, 25 fours. 4 plus 4, it is 8 ohms. Therefore, R equivalent value here it is 8 ohms. Now I know that VTH, which is 40 volts, and RTH 8 ohms. If I know that VTH is equal 40 volts and RTH is equal 8 ohms, now I am going to recall that equivalent circuit. In equivalent circuit, there is a open circuit voltage or Thevenin's voltage, that is 40 volts, and Thevenin's resistance RTH or RT is equal 8 ohms across the terminals AB. So whatever I removed that resistors across the terminals AB in the given problem by the time of starting that solution, that is this one, 2 ohms resistor. Now I have to connect again in series with the terminals AB. If I connect again in series with the terminals AB, then the circuit has been become as like this. Here AB onwards, here I am connected that 2 ohms resistor. Now this is very simple circuit compared to that given circuit in the problem. In the given problem, circuit consists of 2 loops. Now the simplified circuit consists of only one loop. What is the current which is flowing in this loop? That is called I. That is our ultimate solution. Therefore, I is equal here V by R equivalent. Here V means 40, R equivalent means 8 plus 2. So 40 divided by 10. So I is equal 4 amperes. Therefore, according to the given problem, the unknown parameter I is equal here 4 amperes. That is the solution for the given problem. Thank you.